All right. So what we're going to do, we're going to kind of relate this back to the quadratics for a minute. When you were, and this is, I know y'all like titles, this is factoring and solving. We've already factored and solved quadratics. Yeah. This is factoring and solving polynomials. Now, this is one of those things, a quadratic is a polynomial, but a polynomial is not always a quadratic. Does that make sense to you? It is just like the square and the rectangle thing. Okay? A square is always a rectangle, but a rectangle is not always a square. Okay? Because by definition, polynomial is one or more terms, and a quadratic has a maximum of 3 terms, right? A squared, an x, and a constant. All right, so we factored and solved quadratics. You remember doing that? Maybe we had something like x squared, we'll make this one easy, plus 5x plus 6 equals 0. And if I said to factor and solve that, what would you do?
Well, it's a perfect number. No, it's not perfect.
The box, right? We'd factor it, in other words. Right? Are you with me, Juliana?
Okay. Oh, this is the box thing.
Right.
You're like factoring. That's what you mean. No.
Yeah. No, it wasn't.
No.
Okay. What multiplies to 6x squared but adds to 5x with the same sign? 3x and 2x. And so we factor up and over x. What's the GCF here? 2.
Oh, God.
What's the GCF? X. What's the GCF?
3.
And the reason
3x.
well, this one would have to have an x on it for that to be a 3x. So it's just
it's over. 3x and 6. Yeah, but
would be 3 would be the GCF. All right, so the point, what I want you to get from this is the point in doing this, remember, is that once it's factored, then I've got 2 pieces that are being multiplied together to give me 0, yes?
Yeah.
Which means what?
Wait, what?
If 2 things multiply to give you 0, what does that tell you?
One of the results will be 0.
So either,
X plus 2 equals
Correct.
0 or x plus 3 equals 0.
so that means x is -2 or, and we talked a lot about where this equals 0 is what graphically?
We just did this.
We did just do this. The x-intercepts, absolutely. Good job. So where it crosses the x-axis, we're going to extend this concept a little bit. Okay? This was quadratics. Let's say, though, I had something.
Is it hard?
No.
We'll probably have to do it.
We're not doing that.
Let's say I gave you that.
Well, first you're going to have to distribute out the x.
And I asked you to solve for x. But wait, look at it closely. It equals 0. Say it again.
Equal to 0.
Yes, absolutely. It doesn't matter that there's more than 2 pieces now. It's still things being multiplied. Here's thing 1, thing 2, thing 3, thing 4. Does it still hold true that 1 or more of them must be 0?
Yeah, so it's going to be x.
Guys, I need y'all to put these tablets away because I feel like they're being a distraction.
All the parts to 0.
Yes. We set all of the parts to 0.
Why does it say x equals 0?
Isn't this a part too?
Oh, yes, that is.
Guys,
That wasn't me. I said what?
I'm going to do this all at one time here. Okay, so I get how many answers this time? 4 answers, which means what is this graph doing?
Multiple things.
What'd you say? Possibly, well, maybe not, maybe, but what did these indicate to me? It's crossing the x-axis. I don't know what else this graph is doing, but I know at 0, at 3, at -0.5, I don't have room.
Big tiny line.
And at -5, it's crossing. It could be doing all kinds of, actually. It could be doing all kinds of other crazy things. I don't know what it's doing, but I know that at those 4 points, it's crossing the x-axis.
You can create 3
Okay.
problems out of that.
Well, these are polynomials, so they're going to look a little different. All right, so I tell you all that because we're going to be doing this with our polynomials. So we're going to learn some other ways to factor, because all we know how to factor are quadratics, right? Yes, Miss McGee. Yes, we know how to factor quadratics, right? Quadratics have a degree or a highest power of what? 2. Okay. So when the power goes up, the question is, can you still factor and solve it?
Yeah.
All right, so let's talk about some factoring methods then. First thing is not really a special pattern, but we say factoring completely. And factoring completely simply means that I factor it the first time, and then I look at the factored pieces in there, the parentheses, and I check to see if I can factor them again. Sometimes you'll be able to factor a lot. You have to continue asking yourself, can you factor it anymore, until the pieces can't be factored any further. So, for example,
It's like a factor key.
it just keeps going. Can that be factored?
No.
I heard no and I heard yes. Yes, this is a special pattern. This is actually on your sheet. We talked about this whenever we did quadratics, but it doesn't necessarily have to just be a quadratic. This is number 1 on your sheet. Difference of 2 squares. Remember when we did difference of 2 squares? If you have 2 perfect squares separated by a subtraction sign, how does it factor? The square, keep going. The square root of the first, what's the square root of x to the 4th?
Squared.
X squared
I said better.
minus 4,
You do that again.
and then you do that again.
Squared plus 4.
Good job.
Yeah.
Okay, so that's factored. But my question to you is it factored completely?
No.
Why?
You can still square it.
Look at that first piece.
So it's going to be x minus 2.
Yes. And x plus 2. How about that x squared plus 4? Can you factor that again?
Didn't you just do that?
I did the minus here. What does your sheet say? Does it have a sum of 2 squares?
No.
No, it's just a difference, right? So I can't factor that, so I write it. Now it is factored completely because none of the parentheses can be factored any further.
Why can't x plus 4 be?
Yes, because it must be a
Negative?
subtraction sign, yes. Questions about that? Does that make sense?
Wait. Why did you x squared plus 4? You keep going with that.
Because it has to be, it only works whenever it's a subtraction in the middle. It's difference of 2 squares, not sum of 2 squares. This can be factored. This cannot because of the addition sign. Does that make sense?
So you can only do 1.
Correct.
So you don't do it again because you can't go to 2.
Right. Only perfect squares that are separated by a subtraction sign. All right, so from now on, everything will need to be factored completely when you factor. Let's look at another. We actually have, let's see if that's 1 and 2,
I thought we were
3,
dividing.
4. I forgot we have to do this first. This is a form of dividing, and hopefully that'll all pull together for you tomorrow on how it is, but you shall see. All right. Y'all ready for the brand new stuff? Yes, we've already learned some of them. All right. Sum of two cubes and difference of two cubes. Here's where it gets a little bit confusing because remember with the squares one, it had to be difference only. It couldn't be a sum. When you're talking about cubes, I have a sum or a difference. I don't know an easier way to tell you to know how to do this other than to memorize the pattern here. Okay? What is a cube, by the way? What does that mean? Power of 3. Okay. Let's see. X cubed plus 64. And so this one will do x cubed minus, we'll just do 8. Now on your sheet, this is number 3 and 4. And I'm not going over perfect square trinomials on there. We've been over that a bunch of times. I'm not going to go back over that yet. Sure. Welcome. Here's what you do. Set up 2 sets of parentheses. A little one and a big one. Put your signs in there first, okay? And this rule is the same whether it's a sum or a difference. So I'll give you the example as a sum, then we'll do the difference together. All right. Your signs are going to be same, change, plus. You're going to have a binomial times a trinomial. So it's going to be same, change it, second one's always a plus.
What if same and just leave it?
Yep, whatever you started with.
So.
All right.
Third part
Is always plus. Always.
and the second one is always.
Well, if you start with a sum, yes. It's same, change, plus. What times itself 3 times gives you x to the third? X. That's the first spot. What times itself 3 times gives you 64? 4. 4 times 4 is 16, and 16 times 4 is 64, right? Are you following with me? If you need to think about your cubes and write a list like what we do with our squares, write them out so you remember, so you can, or at least start to recognize them. Huh? You want me to write them for you? Let's see.
Well, that's the squares on the board.
That's the squares on the board, yes. 2 to the third is 8. 3 to the third is 27. 4 to the third. 5 to the third. 6 to the third.
We can't see it.
Oh no! My board's off.
So 24, 64, 125, 160.
Yes. 8, 27, 64, 125, and 216.
You want to repeat that?
343 is 7 to the third. You don't have to go much further than that. All right. So we got, does everybody see where these first 2 numbers came from? Okay. Take the first, square it, and put it in the first slot here. What do you get? X squared. Take the last, square it, and put it here. Now, multiply these 2 together and put it in the middle.
I have a question.
Okay.
Can you repeat how you got those?
Okay. The first one, squared in the first spot.
Yeah.
The last one squared goes in the last spot.
How'd you get those in that box? Is that just random?
What box?
Well, the first number, x plus 4.
That's what times itself 3 times gives you x cubed.
4 squared.
What times itself 3 times gives you 64.
Oh, okay.
So then, how do you find? How would you find the 4? Would you multiply by?
You multiply those two. Once you have those first two pieces, you use those to write the rest.
So 4 times itself will give you the last one. That's what it would.
Yes.
So.
If you look at it in variables, and I'm going to come back to this slide, a cubed plus b cubed factors as a plus b, same, change, plus. You square this one, you square this one, and you multiply them together for the middle. This is very close to a perfect square trinomial, but it's not because the middle's not what? Somebody please get it. Multiplied by 2. Good job. It's not double the product of the ends. It's just the product of the ends. So it's on your sheet as this and as an example. Does it make sense? Tanner's frustrated. Are you frustrated?
Zoned out for like a minute and then I got off.
You zoned for a minute, is that what you said? We're gonna do another one with the difference. It's the same pattern. Difference of 2 cubes, we recognize that these are both perfect cubes, yes? You need a little parenthesis, you need a big parenthesis. Same, change, plus, so what are my signs gonna look like? Minus, what's next? Same, change it, and plus. Same, change, plus every time. What goes in the first spot of the binomial there, the first set of parentheses? X, because it's what times itself 3 times gives you this.
And then the other side's going to be x2.
Yes, this is going to be x squared. You're absolutely right, because I square it to get this one. What times itself 3 times gives you 8? 2. Again, when you square that end, it goes on the end of this one.
Mm-hmm.
For the middle,
Multiply
yep, 2 times x.
times 2. So wouldn't that be negative 2?
Don't worry about the signs because we arranged the signs before we started.
How'd you get to
Multiply these two together.
And that's it.
For that. Let's do one slightly harder.
Oh, I thought this was the hard one to get.
This is 2 of 4 that I'm showing you today.
105.
We might not make it through all 4. We're going to try. We'll get through what we get through, but we don't. What? You got a lot to say today, don't you?
Yeah, I don't know.
You do? Yeah.
Is the difference the same as how you do this?
The sum? Yes.
Oh, this?
Yes, they're the exact same pattern. All right. Remember, my first step to factoring is always to check for what? A GCF. Okay, always. So here's what I want to do. The directions simply say factor completely. So I look at this and I go, oh my gosh, I see a 5th power. Oh, you shouldn't see an X and a Z.
I knew something was odd about that.
You knew that, didn't you? Picked that right up. Does that have a GCF? Can I take something out?
2 x's?
I could definitely take 2 X's out. Anything else? Does 4 go into both of them? 2? 2, yes. 2 and 2 X's. What's left? 8x cubed minus 125. Is anybody confused at this point? All I did was take out a GCF. I divided both of them by 2, and I took 2 X's away from both of them. Yes? Look at what's in parentheses now. How could we maybe factor that?
So we're only factoring inside the parentheses.
Now we're looking at inside, because that's what factoring completely does, is it looks at what you've done and looks at the parentheses and keeps on going. So do you see anything there?
So we'll multiply it by the 2x later.
We'll just keep it out front. We'll keep it out front as part of the factoring. What do you notice about these?
Nothing.
You don't notice anything about those?
That the 8 is before
They're
the-
both cubes. They're both cubes. 8 is a perfect cube and 125 is a perfect cube. The other thing that should clue you in, there's only 2 pieces and there's a power of 3 right here. Okay? So I'm thinking difference of 2 cubes. Put the 2x squared on the outside. And set up your parentheses. Remember, little and big. Shammy. Give me the signs on this.
You do on the first box minus,
Mm-hmm.
and the second box plus, so you gotta change it in another plus.
Good job. Moo-Moo's on a roll today.
I told you I'll be paying attention. You have to be thinking of yourself.
What times itself 3 times? What happened? Did it bust? Oh, it just popped off. 2x. Because 2 times 2 times 2 is 8, and x times x times x is x cubed, right? What about 125? Good job. Is anybody confused? We all on the same page? Now we start squaring them. What goes in the first spot? Nah.
I got really confused.
Good job. 4x squared. You have to square both pieces of it. You were close.
So 5
What about the end?
to the third.
What goes here? 25. How about the middle?
10x.
Tell me what you think sum and difference of 2 cubes.
I like that.
So, okay, no.
It's straight. It's straight.
Tanner said,
It's like that.
See, this everybody gets and I don't.
it's a pattern you have to memorize. And if you remember, same change plus, and use your sheet as you go through. I promise after you do a few of them, you start getting the hang of it, it'll start picking back up for you. Golly, y'all. Let me show you grouping, and I'm going to save the 4th form for tomorrow.
Just say both of them for tomorrow. Don't worry. I don't even remember the first one. I always thought we were going to learn one today. I thought the first one.
Let me pause while I look at the grouping with you. Let me show you the 3rd pattern. And we'll save the 4th pattern and the solving and kind of putting everything together. Tomorrow, I won't tell you. Today, for your homework, I'll tell you which method to use. I'll say factor the following sum of 2 cubes. Factor the following difference of 2 cubes. Factor the following by grouping, which is what I'm fixing to show you. But tomorrow, we'll pull everything together where you have to decide what the pattern is yourself.
You can do which one you want on any problem.
No, it has to meet the criteria. I mean, you can't factor a sum of 2 cubes if they're both squares and not cubes. You see what I'm saying? All right. This is a method. If some of you factor a different way other than the box, you may already know how to do this. Ms. Wilson does a similar method to this in her factoring when she does all of her quadratics. This is factor by grouping, okay? It looks kind of complicated, but once we get through it, I think you'll see what's happening. Okay? I think the easiest way for this is just to jump right in. These will have 4 pieces to them. And that's going to key you in straight off that what we're doing is factor by grouping. I call these slasher problems because here's what you're going to do. You're going to slash this polynomial right in the middle. First two terms on one side, second two terms on the other. And we're going to look at it as two separate problems to start with. Okay? So look at the first two. Is there a GCF that I can take out of the first two?
No.
X what? Squared. Just these two, Shami. Not anything on the other side yet. Just these two. If I said, what's the GCF of x cubed and 7x squared? You would say x squared, right? What's left? X plus what? You must keep the middle sign. That has to stay. Look at these two. GCF. 9. Do you agree? Careful because I'm actually taking out a negative 9, right? What's left?
X minus something. 6.
Do you see why I changed that to a plus?
Yeah.
If this is a subtraction sign, that means I'm factoring out a negative, and a negative divided by a negative is a positive. Now look at this with me for just a minute. You really got to kind of wrap your brain around this. Because anytime this middle sign is negative, I have to keep the middle sign. So I'm really taking out a negative 9. And remember, when you take something out, you divide it to find out what's left.
So you're always going to have a positive.
If the middle is a negative, it's always going to change the last sign for you. All right. If you had the equation or the expression, don't write this just yet. I'm just writing this to kind of help you. X squared y minus 9y. And I said, what's the GCF? What would you tell me?
I'm proud.
Huh? 1 what?
1 and 0.
Look, what do they both have in common that I could divide them both by? Y. Do you agree?
Yes.
I could take a y out of that. So would you then understand that if I looked at this expression in blue, that I told you the GCF was x plus 7? Does that make sense? So if I have a GCF, I can take it away from everything, put it in the front, right, and write what's left. X squared minus 9. I don't write it twice. Everybody wants to write, I don't write it twice because just like if this was x squared y minus 9y, I would just write the y one time and put it out front, right? So I do the same with this chunk here, this x plus 7, and put it in the front. Does that make sense? Really? Is it factored completely?
Yes.
Careful.
No.
Look at that x squared minus 9. I told you factoring never goes away. Okay, wait.
How did you get the x plus 7?
Here's that one.
The x what?
What?
Oh, I get it.
Can
Alright.
you go back to the x plus 2 that or before?
Here.
Yes.
Okay.
How do you get from there to the next?
Okay. This x plus 7 is a GCF. Okay. Just like if instead of x plus 7 it was a y there instead, and you could pull the y out front. Instead of it just being just one variable, I pull this whole thing out front here. And they have to match exactly for it to do that.
And how did you get x squared?
Okay, so when you
got
take
that.
that away from everybody, what's left?
X squared minus 9.
Right.
So because they're both on the same side, they'll cancel out.
Because you're
always like
taking
that?
it away from both of them. Yes, it's always like that.
So they're both gonna always be the same.
Yes, if they're not, it doesn't group. Somebody said something about the x squared minus 9. What was it?
And then
It'd be
what?
x plus 7, x minus 3, x plus 3.
Yes.
And then what?
Juliana, what's your question?
How would you get the x plus 7 again? If both of them canceled out?
They didn't cancel out. I pulled it out and put it in the front.
So I did that right.
And then you group the x squared ones.
Yes. Now it's factored completely because none of these pieces can be factored any further. One more. We're going to do one more of these.
X plus 7.
Most students like the grouping for some reason.
At least
Better than the other one.
the other ones, I like them. The other one's cute.
Let's try this one.
No problem. You.
I'm going to give you a second to work this on your own while I write the homework on the board. So it's going to change a little from plan book. I hope that you at least pulled out the GCF from the first two terms and the second two terms. You got a question?
I did it.
16, is that true?
48 divided by 16 gives you 3, so that's your GCF there.
But I
thought
got
it was 2.
plus 3.
16 times 2 is 32.
Oh.
Then another 16 would give you the 48. Tyler, when the middle sign is minus, that's okay. When the middle sign is minus, it changes this sign. No, I didn't.
Yeah, you did.
Did you?
Yeah.
But you didn't even catch it. Great, y'all. Thanks for tattling on me. Yeah.
That makes everything.
Yes, that's good job. All right, take the common factor out front. Shh, guys. Mumu, can you factor it anymore?
Yeah.
What?
X minus 4 squared.
How does it factor?
X minus
X
4,
minus
x
3.
plus 4.
Good job. Not quite quick enough there, Tanner. Tanner, Tyler, it's all the same thing, right? All right.